Hello, this is Lucky Kushwaha from Physics Department at IIT Roorkee.
And I am Harshini Paranajpe, and this is the part 1 of our presentation on multiple peripherals using 8085. And I am Harshini Paranajpe, and this is the part 1 of our presentation on multiple peripherals using 8085. The goal of this experiment is to use multiple peripherals with an 8085 microprocessor. Here we have used a 7-segment LED display and a DC motor and controlled them using an 8085 microprocessor kit. So the aim of this experiment is to change the speed of the DC motor and simultaneously display it on a 7-segment display, and the speed will vary from FF to 0 and it will be displayed on a scale of 10 as shown over here. Now first let's look at the basics of 7-segment display, then we will go over to the algorithm and then we will see the implementation. So in order to display a number or a letter on a 7-segment display, we first need to know whether it's a common cathode or a common anode type. So the one we have in our lab is a common anode type, where all the anode connections are joined together to get a logic high, and one needs to ground the LED which one wants to light up. So we need to provide a 0 to the LED which we want to light up. So for example, if we want to display a 6 on the display as it is shown here, then we will start from 1, that is the decimal point shouldn't light up, then 0, 0, 0, 0, 0, 1 and a 0. Then we convert it to hex and we will get 82. So in a similar fashion we get the hex codes for all the display numbers from 9 to 0 and then store them in the appropriate memory locations. Now each number we display is a character and it's made up of 8 bits, and the character counter tells us how many characters we can display. So if it is 5, then 5 characters will come in a rolling fashion. So for this particular experiment we need the character counter to be 1. Now let's have a look at the algorithm of the code which will come next. So first of all we need to run the motor at 10 different speeds. So there will be an outer loop which will run 10 times. For that we initialize the outer loop counter to 10. Then we initialize the maximum motor speed to FF. So the motor will start from this speed, and then the display character hex codes are stored as a list in the memory and the memory location has to be initialized. So we do that. After that we come to the outer loop. It's a while loop, and with every iteration of this loop the motor will change its speed to some value and the display will first blank out and then display the motor speed. So for all of this there is a code block for blanking of the display, and then we retrieve the hex code of the character to be displayed in this iteration. Now we initialize the character and bit counters to 1 and 8 respectively. Then in one iteration of the character counter loop the following things will happen. So first the bit counter loop runs 8 times and a single character is displayed, and then we retrieve the motor speed for this iteration and the motor is run at this particular speed. Then we introduce a delay of 2 seconds and then we decrement the character counter. So in this way the outer loop runs 10 times and then we stop. So this is the experimental setup which has been explained properly in the part 1 of our presentation.
Let's go through the implementation part. What we have to display should be stored somewhere in the memory. So for which we have taken the array data structure and the array data structure. So we have stored the array, our array, to start from the memory starting location 2100 hex, and where character 9 is stored, similarly 8, 7 and so on. Now we have to store the starting address of this list somewhere in the memory. So for that we have taken 3100 hex address and stored the starting address of this list to this location 3100 hex. Since 2100 hex is 2 bytes data, so it occupied 2 memory locations each of 1 byte. we need one more location where we can store the speed of motor, and for this 3200 hex memory is used. Initially its value is ff, which is the maximum speed of the motor. As the number of iteration progresses, speed will keep on decreasing and this memory location will get updated. Similarly, here also, in every iteration, this memory location will be updated with the address of the latest value of the character to be displayed. So before going further, what we need to do is whatever there is displayed on a 7 segment, we need to first clear it out. This is the clearing code for this 7 segment display. So after clearing, now we are good to go. So this is one iteration I am explaining. In every iteration, what we need to do, we need to first fetch the data. As I explained above, 3100 is our memory location where we have stored the starting address of the list. So we need to first load that data. We have to load the data from 3100 hex. So this is the code for loading the HL pair with the starting address of character list, and here you load the data, modify it and save it back to the original place. Now coming to the bit counter loop, we have a total of 8 bit including the decimal point. This is explained in the previous slides. So there is total 8 bits including the decimal point to represent a character. We have to port out all 8 bits of character to display a single character. Hence, this should loop 8 times in every single character to be displayed. For instance, in first iteration, it will read from the memory 2100 hex and port out 9, and this 9 will be displayed on the 7 segment interface. So this is the code for bit counter loop. As this since this 9 is now displayed on the 7 segment, now our task is to immediately set the speed of the motor to its to the corresponding mapped value of 9. So we have got the motor speed at 3200 hex and loading it to the accumulator using the LDA command, load directly to the accumulator, and sending it to the port 40 where the DC motor controller is connected, and lastly decrementing the speed of motor and saving it back to the very same location. So till now, summarizing, in the first iteration we have displayed the speed and also set the speed of the motor to its maximum. Then in second iteration, the display will show 8 and the speed will be set to its corresponding mapped value, and this will continue up to the speed 0 where the motor will be turned off. Everything seems fine till now, but there is a catch. If you do exactly the same as above, you will notice everything will execute too fast to be noticed. To tackle this, one needs to introduce the delay between two iterations. So this is the delay code for 8085 microprocessor. One iteration of this line will generate 0.5 seconds of delay. Iterating over it 4 times will get a delay of 2 seconds. So everything explained till now is one iteration. Creating the outermost loop and fitting the whole code inside this loop will make it run more than one time. Here we need it to run 10 times because we have 10 different speeds. Here if you observe, at the end of every iteration it will fetch the counter variable from memory location 3000 and modify it, that is decrement it by 1, and save it back to 3000 location, and this will continue until it becomes 0. Before running the above program, it is assumed that speed of the motor will be stored at 3200 and character list starting address will be stored at 3100 and also the outer loop counter at 3000 hex. So either we should do it manually by going to the corresponding memory location or write the initialization code. So here is the initialization code for initializing the values at the given specified directions, and this is the full code for the 8085 microprocessor. Thank you.